Today we are examining the complex high stakes military operation that is an orthomyxoviridae infection, specifically influenza. Looking at the overview of this image, we see a virus that doesn't just attack, it uses strategic tools, clever disguises, and specific escape plans. We will treat this illustration like a crime scene, deconstructing every element, moving through the viral life cycle to complications, diagnosis, and therapeutic interventions. So, look at the center region. Inside, we see segmented, single stranded, negative sense RNA strands. Influenza A and B have 8 distinct RNA segments. However, C and D, the lesser virulent ones, do only have 7 distinct RNA segments. This segmentation is the key to the virus's identity and its ultimate danger. Think of these as 8 distinct scrolls of laws and honor from Mulan. If even one scroll is swapped during co-infection, the entire virus gets a novel identity. The most critical glycoprotein spike seen around the entire periphery is hemagglutinin. Biologically, it's the attachment protein that binds sialic acid receptors on the host epithelium. Notice they are drawn as glass slippers. This is because the binding is highly specific, like Cinderella's glass slipper. The HA glycoprotein must find the precise sialic acid receptor, the perfect glass slipper fit. If it fits, the virus has its mandatory invitation to the ball. That's the interior of the cell. Neuroaminidase, the midnight deadline or the scissors. The second major surface glycoprotein spike, also seen extensively, is neuraminidase. It is an enzyme that cleaves sialic acid residues. Notice they are drawn as standard scissors. New variants often tether to sialic acid after forming. Na acts as molecular scissors, cutting those tethers. This enzyme is the midnight deadline. It's the only way the virus can escape before getting caught by immune system and gets to the next cell. The strategic infiltration. Now let's trace the actual infiltration process, moving vertically down the left flow diagram from step 1 to step 4. Entry. The virus that is our Cinderella variant, attaches. The HA glycoprotein binds sialic acid receptors on the respiratory epithelium. Once bound, the host cell endocytoses the entire variant. So this is a key event. The virus must uncoat inside the endosome. An M2 ion pump channel pumps protons into the virion, acidifying the interior and unmasking the RNA genome from its matrix cell. So this M2 coating step is what the classic drug amantadine blocks. Note the arrow entering the inner purple membrane. This is the host cell's nucleus. This is unique for RNA viruses. Unlike polio or measles, which replicate in the cytoplasm, influenza replicates in the host nucleus. The newly made RNA segments travel to the cell membrane to form a new bud. Once formed, they must cleave from the membrane to release. This is where neuraminidase, the scissors, perform the crucial function, cleaving sialic acid. The masters of disguise. Why does influenza cause pandemics and epidemics? The virus has plot twists to evade the immune system, characterized by changes in its surface glycoproteins, that's HA and Na. This is a continuous process. We are talking about antigenic drift. So it's basically the costume change. Gradual point mutations in HA or Na genes that occur during the replication. This is like Tiana wearing different gowns. It's fundamentally Tiana, but the immune system guards must take a double check before recognizing her. So it causes seasonal epidemics. Antigenic shift is a multiverse crossover event. So this is a critical pandemic concept, a drastic sudden change occurring via genetic ressortment. This happens when two different influenza strains co-infect the same cell, classically within a pig. So it's basically the mixing vessel. Bubbles seen with a pig, bird, and human icons. The viruses swap RNA scrolls to form a novel virus. So this is a multiverse crossover event. Imagine a character combining Mickey's ears, Elsa's power, and Maleficent's wings. The policeman, our immune system, has zero previous experience with this weird entity in the right corner. This dramatic shift leading to pandemics and occurs only in influenza A. Complications. So it's our pathogenesis. Opportunistic henchmen. A common cold is a nuisance. Influenza is systematic. It targets upper and lower respiratory tract, leading to tracheobronchitis. Look at the lungs on the right. Influenza can lead to several severe complications. Primary viral pneumonia, direct damage from the virus itself. Secondary bacterial pneumonia. This is the most common cause of death. By damaging the respiratory mucociliary clearance, it opens the door for opportunists. Think of these bacteria as evil henchmen following the main villain. So it's the most dangerous accomplice is the Staphylococcus aureus or Streptococcus pneumonia. Now let's get into our lab diagnosis. For definitive diagnosis of which villain has invaded, look at the bottom right. Clinical specimens like nasopharyngeal swab must be collected early, like within first few days of illness. While rapid molecular tests like RT-PCR are golden standard today, classical methods are still high yield. In lab, the virus is inoculated into embryonated specimens, pathogen-free hen's egg, especially into the allantoic cavity. Look closely at the egg. You inject the specimen into the allantoic cavity. This is where primary isolation, especially of influenza A and B, occurs. Prophylaxis and treatment overview. We defend our kingdom with two strategies, divided between prevention and treatment. Look at the far right shield, the nasal spray icons. The goal is to produce protective anti-HA antibodies that provide immunity. A killed virus vaccine given via an standard infection shot is basically the standard shield. Live attenuated influenza vaccine, it's a weakened virus given via nasal spray. Crucially, it's contraindicated during pregnancy in immunocompromised states or severe allergy to egg proteins. Now let's look at the treatment. The superhero putting the padlock on the virus. So these are drugs like oseltamivir and zanamivir. So they function by handcuffing the Na enzyme, blocking the midnight deadline escape. Notice the padlock is specifically on the Ni-glycoprotein, that's the scissors. M2 channel blockers, so this is the other superhero. So while amantadine is less commonly used today due to high resistance in circulating strains, its mechanism is by blocking uncoating or acidification is still a high yield concept. It locks the variant shell to prevent the unmasking of the RNA scrolls by blocking the M2 channels. So we have deconstructed every element of the illustration by understanding the segmented genome as scrolls of assortment, HA as Cinderella slip of it, NA as midnight scissors for escape, and identifying the drug targets. We now have a comprehensive high yield mastery of the influenza virus, prepared for both clinical practice and exam scenarios. Good luck with your studies. Keep studying the book. Go and read your text before you start writing the concepts.